We'll move to Professor Michelle Johnson, who is an associate professor of physical medicine and rehabilitation at the University of Pennsylvania. And so Dr. Johnson's lab specializes in design development and the therapeutic use of novel, affordable, and intelligent robotic assistance for rehabilitation. So Michelle, please take it away.
All right, thank you guys for having me. As usual, I always over-prepare. So given that we're running a bit behind, I'll try to make sure that try to end on time. So I actually I didn't get a chance to send my slides, but I was thinking about the idea of inclusive rehabilitation for high and low resource setting. And I kind of wanted to theme around this idea in my talk. And the two areas that I think interplayed within this discussion is on challenges and opportunities. And I'll talk a little bit about some of the affordability type thinking that we've been doing, and this idea of inclusivity, which some people would argue is also included affordability, but I'll separate the two because one I think of in an economic sense, and the other I think of more in a wider kind of neurological or clinical sense. So, I mean, probably many people have been thinking this is out of date because I think COVID should be probably 1 or 2 now when we think about all the things that are causing death. And I always talk about diseases because pretty much all diseases lead to some type of disability. HIV, cancer, road injury, all kinds of things. And a variety of disabilities will result. And majority of the time, as roboticists in neurorehab, we're focusing, on motor injury. As I sit in PM&R and sit in this very clinical space, recognizing that diseases lead to complex, even strokes lead to very complex presentations, and that in order for our robots to be more effective, I think we need to kind of deal with those on the complexity as well. So, I mean, these diseases and impairment leads to kind of growing numbers. We still have the issue of smaller or very small clinical care population and this gap. We're all here because we believe that technology can bridge this gap. And our focus originally has always been on, at least for my focus, on therapy robots and making sure that they do 3 things well, that they can automate in some way, some type of therapy, that they can assess in some way, and that they're actually efficient in either treating or diagnosing what's happening. My model of thinking about robots have always been kind of thinking of that the robots are there to support the clinician in a variety of ways, whether if the clinician is playing the role of demonstrator, the robot is there that could then be asked to share that work with the patient. If the clinician is playing the role of helper and actually interacting and holding on to the therapy, that we can then support that, as well as if the clinician is playing the role of observer, kind of wanting to see what is available, that the robot can also do that. And I think in many ways, we've built robots that do such things. I think when we study human-human interaction between patients and therapists, we realize that they're actually doing all these 3. And as roboticists, we've specialized, we've built helper robots, and then we've built assistive robots or observing robots or demoing robots. And oftentimes the robots are not necessarily able to flow through the very complex space of rehab. This is just an example of my older version of a helper robot, and Matei's presentation was clear about, looking at a type of a helper robotic system as well. When I think about demonstrator, we think about the classic, social robots and the work that we've done with Dr. Kuchenbecker in terms of thinking about demonstration and observation. So I've spent a lot of time kind of thinking about, or using and leveraging more complex robots, maybe more expensive robots, to understand disability and to try to shed light on how do we do it? How do we diagnose it, et cetera? My work has, it kind of evolved into thinking a lot about affordability. And I wanted to define it. It's like the extent to which something is affordable as measured by cost relative to the amount that the purchaser is able to pay. And I talk about low resource setting and high resource setting from this perspective, in that low resource setting in many ways can be our community rehab center, the skilled nursing facility, the nursing home, the rural environment in upstate Pennsylvania, but it can also be the low and middle income countries that we work with. And something that's always clear is, depending on where we're going, I think we have to think through these affordable issues. And the problem with many systems, and why we run into problems when we try to be in these low resource settings, is been many things, either mechanical complexity, maybe they're too large, there's no space, it's too costly. The difference between, putting a robot into the hospital setting and then putting a robot into the skilled nursing facility or the nursing home can sometimes be like drastic in terms of what they can afford, where they can put the robot size, et cetera, and then the diversity of patients that they need to serve. So, there are lots of potential strategies to reduce costs, and myself and some colleagues from Italy had done a recent review on this idea. We can kind of rethink, low cost mechatronic systems. We can think about cheaper materials. We can also think about smaller units and thinking about 1 degree of freedom and multiple robots making that and being able to reconfigure them, et cetera. Something that I want to explore kind of one way that we've thought about it and how that's evolved over time. One was this work with Mexico started actually before I got to Penn, when I was at the Medical College in Marquette. And I was thinking like really, really, really low cost. At the time I was thinking robots that's going to cost like $100, or technology that's really, really cheap. So when we started out there, we were like, okay, my colleague went to Mexico. She was in Chihuahua, which is up here. And she was trained at Marquette, went home to work, and we said, okay, let's set up a collaboration. And Mexico kind of illustrated, like 10, 15 years ago, very stark contrast, lots of people would need care and just challenges in their rehabilitation care system. So we focused on stroke, and the idea was, let's think about gaming. Back then we were thinking extra gaming, really simple systems, leveraging like force feedback wheels, haptic technology, blah, blah, blah. And that kind of led to this concept about, TheraDrive. And then we did a study, which actually I thought was unique in that our goal was, if for $29,000 we could deliver a gym where there were lots of different types of technology, computer-based, robotic-based, et cetera, but smaller, very simpler systems. And then whether we can have people work together in a group setting, because at the time there's low clinician, but a lot of patients. So we had this 1 to 6 type dynamics going on. And we did a small case control study where we looked at this, and we had actually really positive outcomes, which kind of led us to say, well, is this portable? Can we use robotic systems or passive or active systems, and we put them together in places where we can break the system down, put it back together in a different country or in the community, and have kind of a low cost group therapy where one therapist can kind of serve the needs of multiple people. So we've explored that. And then one of the key things that we realized was challenges is, when you go cheap, sometimes you often sacrifice power. And in fact, talking to Dr. Sue, we've been kind of working on how do we go, don't sacrifice power, but go smaller. How do we not sacrifice power and get less expensive? But anyway, that led us to kind of think about a system that could support the more severely impaired stroke survivor. Clearly, this person is not that severely impaired, but that led us to the haptic TheraDrive system. and us kind of looking at gaming tools that we can develop and use with the system. And this idea that the haptic robot, while being one degree of freedom, there's a force sensor, encoder, that we can manipulate it in different ways. We can change its orientation, we can make it reconfigurable, and we can use a variety of types of interaction type games with it. So that's kind of where we kind of began our journey of affordability. But along the way, what we were realizing that, and it was inspired a little bit by Mexico, was that when you try to put robots and neuro rehab systems in these low resource settings, what you do encounter is that, one, they're dealing with a variety of patients at the time. So people are going, well, what? Your robot can only do this. What about this? What about that? And so they want more multi-purposeness. The other thing that we realized also was a challenge when you're moving to these places was this idea that, you know what, when you get to Mexico or you get to Botswana, or you get to wherever, people are like, you know, our patients are complex. But when you sit in America, that is true too. Patients rarely have just one type of disability, and it's more like disability compounded on another disability. And so we were thinking of the term of inclusivity, and this idea of inclusive is that equal access and opportunity and resources for people who otherwise might be excluded or marginalized. And in my work in PM&R, I kept on encountering patients that I would say, hey, come and do my study, but oh, you have bad cognition. Oh, I'm sorry, you can't do the study. And that kept on happening. And my clinical colleagues are like, what's going on? You know, why can't you work with these more complex patients? And so that kind of led us to start considering the issue of how do we merge two different impairments together, and how do we study how they interfere with each other and use robots to maybe support our diagnosis of it, and then ultimately to support treatment. So this, my PhD student, Kevin, who just graduated, started thinking about this in terms of our work with stroke. And then HIV is kind of the other place we were going, because we were also working with the population in Botswana. And our goal then was how his goal was to basically look at this relationship between one, leveraging our knowledge from stroke, two, HIV, thinking about cognitive impairment on top of motor impairment, and also how can we look at this from a global perspective? Is the system that we develop in the USA applicable in a different context or a different global context? So why does this work in stroke? But the reality here in stroke is that, hey, 74.77% have motor upper limb deficits, but at the same time, 40% of those will also have cognitive impairment, and sometimes mild and even more than mild. And as a result, my theory as to why some of our work doesn't translate as well when people go back into their daily environment is because that there's interference between cog and the motor. And so when you're in the lab and you're just kind of working on motor, we simplify the cog environment and the load is very low, and so people do well. They go home and the cog load increases and they're unable to then carry out any motor gains. So we wanted to actually study that. And we wanted to also study it in the HIV population, one, because the stroke survivors in Botswana, a third of them had HIV. And we also knew that HIV also caused motor and cognitive impairments as well. So the key thing was, can we build affordable robots that could help us understand these two impairments that sit on top of each other? And if we could, can we utilize this strategy to create treatment algorithms that would allow you to change the robot treatment strategy and the intervention strategy of the robot during neurorehabilitation on the fly? So quickly, just going through this study, we started first principles. What are the clinical metrics being used in motor assessment? What are the key ones being used in cognitive assessments? We wanted to pick metrics that were being used for both stroke as well as HIV. Then there's some classic tasks that we implemented. One that was a trajectory tracking task that was majority motor and some cog involved, but not as much cog. And then a task, so if a tracking task can kind of look at like, you can measure accuracy, performance, range of motion. And here, for example, was one way where we looked at how we could predict a performance error from the different clinical scores that we would collect, and look at the relationship between our ability to predict your accuracy performance, and we could see our actual performance error versus the predicted performance error. We were able to actually do a decent job, if you look at the scoring on the side here, being able to predict these performance error, and that there's a relationship between the box and block is a very interesting, movement paradigm to look at reaching and grasping, and executive function on the motor. And we wanted then a pure cognitive task. And so looking to psychology and this NBAC working memory type task, kind of like folding it into what we were doing. It's a very simple task. It really is not really robot based per se. It's just a button and the person is pure working memory. And then the key thing, then my student goal was we wanted to create a cognitive motor assessment task that had that could increase cognitive load as they go along. And this is what the task, inspired by some clinical assessment task, where there's a memory activity happening, and then you had to move the arm of the robot to do the task. This GIF is essentially showing you that there was a sense of the people with no impairment could handle more complex movements, and the people with a lot more impairment in terms of cog and complex motor and cog impairment, you can see they were able to handle less complex activity. And as we went through 15 trials, we were able to then begin to differentiate the group. Those with both motor and cognitive learning had the worst performance, and the able-bodied group is the group in purple. And you can see then that we were having difficulty extracting the people with motor-only impairment and cog-only impairment. Something to take away from that is this idea that cog-only impairment can actually interfere with motor performance, to the fact that someone with mainly cog impairment can look like the person with mainly motor impairment. And this is why I think in neuro rehab, one of the things and the challenges and opportunities for the future is, how do we tease this out? Because many of the papers in the past never really thought about it or removed this population from the equation. And I think to grow in this field, we need to figure out how to deal with populations that have these multiple type diagnoses. Quickly, one of the goals was then, can we extend and make more inclusive neuro rehab from this perspective of cognition, and be able to treat these folks at the bottom here, which are the folks that are harder to treat using robots. Technically, we've been doing the top part here really well. And so in order to do that, and to be able to know how to treat, we need to be able to stratify people on the fly into groups so that we are able to apply the right treatment. And one of the goals was then, can these particular metrics that we're using with the robot be useful in predicting the clinical cognitive scores? And then if we can predict these scores, then we can use those scores to stratify on the fly. So this is a moderate relationship between that we using our spatial span task, the one that you saw, we were able to predict the executive function score. And then also that same spatial span task was able to help us predict digital symbol coding, which is an informational processing score, and then the color trails, which is about visual spatial processing as well. The other thing is also using the tracking task as well as that cognitive task, we were able to predict the reach and grasp task with the box and block. So I'm going to kind of, because of time, I'm going to jump. The take home really is, if we can develop sensitive tasks to motor and cog impairment and the confluence of both, then we might be able to then predict on the fly motor and cog, and then maybe that would allow us useful online adaptation. So the next evolution was kind of this toward inclusivity and affordability together, and that kind of took us, you know, from America to Botswana, which is Botswana is down here, and a study of kind of where are robots in the world. So like when we look at where's neurorobotics, or where are the therapy robots being built, or social robots, we find that they're mainly in very high income spaces, and not many are in low and middle income countries. And in that sense, it is not inclusive. And therefore there's an accessibility issue and this is particularly at issue because we know that 80% of people with disability, for example, due to stroke, live in low and middle income settings. So from a perspective of opportunity, if we can develop our systems to be able to reach into these settings, I think then we have more opportunity to serve and to support people with disability, and stroke just being one of them. So a part of our motivation and our work in Botswana was to kind of look at the intersection of these two, similar to our work in Mexico, but the population here, we wanted to then port the metrics that we were developing in the US into Botswana, into the population here, and creating a system that could be affordable. Just a little bit of background. Botswana, 4th highest HIV, you know, many of the referral hospitals have 2 occupational therapists, and a hospital might have like 500 beds. And a third of their stroke survivors will have HIV. So looking at the comorbidity or the influence is something that we were interested in doing. That's where Botswana is. We're collaborating, of course, with a variety of partners. One of the things of thinking about affordability in Botswana was trying to figure out how we could drive the cost down of the systems in America, so that we leverage the engineering school there, we leverage in-country materials, we leverage labor, we brought some of our robots over from the US, and we tried to layer on reconfigurability. This is an example of the system, the first system that we put in 2 robots on that rehab care platform, in 2 simple 1 degree of freedom robots on the platform, and in one of the main teaching hospitals in the large city. And then we put a system in a more rural hospital in about 2 hours away from the main hospital. So now we have a system in a private hospital. What our goal was to try to put it in different places so we can get perspectives on feasibility and usability of these systems, and what are the barriers for using them in this low and middle income country. So this is just an example of one of the patients there doing the spatial span task. And this just some preliminary work from my PhD students' result was kind of seeing the differences between the Botswana cohort and the US cohort. And what this drove home for us is, you know, as a community, kind of a lot of times our work is happening globally, but we're not always accounting for the difference is in different global spaces, and how the populations might actually be differing. And some of the norms that we're assuming for in the US may actually possibly not apply to the population in that other country. So in wrapping up, challenges and opportunities. I think I want us to remember, and I guess my point of my talk was, again, rehab is complex. The patients are super complex. And I understand from an experimental standpoint, we need to simplify so that we can understand, but I also think we need to be bolder in layering, you know, so that we can begin to understand more complex layer, exploring comorbidities like HIV and dementia on top of motor issues, exploring and also be able to explore more ways to decrease the cost of these systems so that they become more globally accessible. And then when we're in the global space and we want to test systems, I think I've been uncovering tremendous barriers to implementation, but nothing that I think with some collaboration and partners we can try to figure this out. And the key thing is capacity building. When we move to these spaces where technology is not as frequently used, trying to educate, trying to understand, as well as leverage the engineers there and bring them all up to speed is something that we need to do. Of course, none of the work is able to be done without partners and funders, and then people in your lab. I'll say thank you, and hopefully I picked up some time. I don't know. I know I talked a little bit fast, but hopefully I was able to get you back a little bit on track.
Thank you. Thank you, Michelle.